Our next session, what's next for industrial decarbonization? Please welcome our moderator, Evelyn Wang, Vice President of Energy and Climate, MIT, and Takahiro Ishikawa, President and CEO, Mitsubishi Heavy Industries, America.
Well, good afternoon, everyone. We're here to talk about decarbonizing industry from a global perspective. And the scale of the problem is vast, as many of you know. For example, steel production is attributed about 7 to 8% of global CO2 emissions. If you add that with cement, which is another 6 to 7%, and those are two categories. Certainly there's a lot more when we think about industrial decarb, and that goes from mining to steel and cement to that of oil and gas and chemicals. And the infrastructure costs are enormous. And that's why we're so fortunate to have Ishikawa here with us today to share his global perspective. Tak is the President and CEO of Mitsubishi Heavy Industries America, and he's going to share with us the opportunities and the challenges of industrial decarbonization. So, Tak, it's really great to have you here.
Well, Evelyn, you've always been my inspiration for this climate change space. And your tenure at MIT, your tenure at ARPA-E, I've attended many of your events, and you really are an inspiration to the world for providing ideas and solutions and technologies for decarbonization. Today, we're going to talk about the hard-to-abate industries. We've been a technology and solution provider to industry for 140 years, and we have been producing as an OEM every kind of fossil-burning, CO2-emitting equipment that has ever been invented by mankind. So, in other words, we know how the CO2 is emitted, and we have solutions to reduce the emissions, providing solutions to decarbonize. But as Evelyn stated out, it's really hard because it's not cheap. Policy has provided a framework, especially in America and some other OECD countries. But one solution does not fit all regions because some regions might have the right geology to do massive sequestration of CO2 or massive energy resources underground in geothermal, and also a lot of land and space to do solar or wind solar farms. Not many countries have all of that. America does. But even America, where it has everything that people would want to decarbonize your industry, it's sad to mention that we have the world's largest technology for carbon capture. We have a 5,000 ton per day capture facility that we built back in 2014, commissioned in 2016. And even with the IRA really pushing and opening a door for rapid mobilization, ever since the IRA was adopted, we still have not yet gotten an FID of a carbon capture project, point source carbon capture project. The reason being, it's expensive. And industry and us as consumers, I think, are not yet ready to pay for that green premium. That's the biggest challenge. But there's some light at the end of the tunnel right now. The people that we think, and we've been engaging with them recently, are the big hyperscalers who are wanting 24/7 power. And the only way that you can really get 24/7 power in large scale is to use a gas-powered generation technology, the old gas turbine. But in order to provide a pathway to a cleaner power, today the only solution for that is point source carbon capture. So that is an area that we think can afford to pay that green premium, because their corporate policy, which we all know, has not changed, despite wanting all this power, that they want a pathway to green power. So I'm optimistic that we will see something in the near future that will entail the first FID of a point source carbon capture project in America.
That's a great perspective, and I think it's exciting to hear your optimism in this time where there are certainly many challenges, as you suggested, and given the data center market, I think there is an opportunity to really not only push carbon capture, potentially other innovative technologies. I'd welcome your thoughts as to what potentially that could entail as well.
Sure. Steel also accounts for about 9% of CO2 emissions in the world. For every ton of steel, using the old conventional blast furnace process, emits about 2 tons. This is, again, another very hard to abate industry. But we're making strides to develop technology using hydrogen as a reductant and using iron ore material where you do not have to pelletize and agglomerate, thereby decreasing the carbon footprint. We're launching a project in Europe with Festalpine, Rio Tinto, one of the largest iron ore companies in the world, and us. So we hope that will start a gateway for technology innovation in iron making. But the scalability is still very small. The first unit that we're doing is only 100,000 tons. The world produces 2 billion tons of steel. So there's still a long ways to go. But I think we're going in the right direction.
Where do you think the opportunity is to unlock that scale? Right? Because scale is the bottleneck here.
It really is. Well, everything still uses energy. When you're producing hydrogen, you need energy. When you're capturing CO2, you need energy. America has one of the cheapest sources of energy. It has vast land where you can deploy a lot of technologies, including wind and solar, and maybe even perhaps nuclear as well too. So if America can't do it, and this land of technology, land of opportunity, land of entrepreneurship, if America cannot get it right, I don't see too many areas in the world that can. And America is so good at marrying smart capital to smart technologies. Look at all the companies, the 10 biggest companies in the world that all did 0 to 1 technologies, all American companies.
That innovation is certainly so important for our U.S. ecosystem, and certainly as an academic, I appreciate the pipeline innovation from the early stages all the way out to commercial scale, where we certainly rely on the industries of the U.S. to really do that.
But the U.S. has this combination of academia attracting the best talent from all over the world. And there are risk-taking capital that nurture these technologies. The ecosystem in America, where entrepreneurs meet VCs and risk-taking capital, this ecosystem, everybody tries to copy that, but it's so hard. We've tried it so far in Japan. It's really not taken off. This is really America's trademark.
So let me come back to something you just said. You said nuclear as a potential solution, and certainly nuclear is hot again. And where do you see the opportunities and where are the challenges there?
Well, we built 24 nuclear power plants for Japan in the last 55 years. After the Fukushima incident, all of them went down. So 55 nuclear power plants in Japan all went down. So gradually, one by one, we have 15 that's back on stream. But the challenge of nuclear is that unless somebody really does new builds, the technology to build nuclear is going to be lost. The last plant that we built is almost 20 odd years ago. So managers that were doing that 25 years ago are already retired or retiring. So the technology base is gone. The thing about America, again, America has the greatest naval fleet. Every single submarine, every single naval carrier of the American naval fleet has an SMR on it. It's been a perfected technology by America. They just don't call it SMRs on the naval ships, but the technology is there. So with this renewed interest in nuclear, I kind of wonder, why is there a need for 80 design sets for SMRs? Why does it has to be reinventing the wheel when America has already perfected this? For commercial nuclear today, for the conventional, it's only the BWR and the PWR, the pressurized and the bubbling water reactors. They standardized it to 2. It may have taken some time to get there, but it's been like that for the last 50 years. SMRs for government and industry to support SMR development. I think government can take a lead combined with academia, especially institutions like MIT, which is the top school for nuclear, to really kind of come up with a standard. This is what nuclear should be. This is what SMR is going to be, and really consolidate everybody's effort to really speed up the development.
That's a great perspective, and certainly, like you said, there are many SMR companies that are extremely exciting, as especially in the light of the need for data centers, AI, electrification, and I guess what I'm trying to understand more is certainly there would be great to have a standard and having academia be involved, but there's also a race right now, right? So maybe the first one out to show the actual ability to deploy nuclear may not be the best technology.
True.
But how do you kind of reconcile that where meanwhile there's maybe a thinking about standards, like this kind of, how do you kind of think about that kind of mismatch potentially? Or are they either going to be the standard because they're the first out of the gate?
Well, as you said, there is a race for who will get really the first project off the ground. Some of them are funded by big pockets, the hyperscalers as well too. But whoever is really authorized as a design by NRC is, at least it goes through a rigorous process. The American government has certified that. And there isn't any other government body in the world that is really equipped and qualified to certify this. So that's, I think, a litmus test. So we, as a soup to nuts nuclear power builder, we get contacted by a lot of people to invest, help with your technology, but we can't deal with 80 design sets. So we always have to tell the SMR developer, well, come back to us when you have a design that's ready to be approved. Because we will provide the components, because we're probably one of the very few that has the capability today, at least, to do a soup to nuts solution for nuclear reactor. Go ahead.
I want to come back to your earlier comments on how there's such a unique ecosystem for innovation. And I know MHIA also invests in a lot of startups. And how do you see that in terms of your strategy as you're thinking about industrial decarbonization holistically?
Yes. The innovators in America, and some that come from your lab, Evelyn, yes, they are really the cutting edge. They do 0 to 1. Our firm, we're very good at doing 1 to 100 or 1 to 10. 0 to 1 is really hard. You need to have an ecosystem, as I explained earlier, to really make that work. So we supplement our own R&D work with what we have here in America. That's why we have 13 startups in our portfolio here in America, and soon to be 15 in the next few months. And some of them come from your labs, some come from other accelerators, some come from other introductions, but each one of them is very unique. It's something that did not come up from our own labs.
Where do you see where they can learn from your experience and a company like MHIA that has done so much in this space? Where do you think the pitfalls are that they could learn from? Curious.
Yes, but the solution is really hard. I'm sure you've heard the word valley of death. So these startups are great at coming up with ideas and creating a prototype with seed A, B, C, D capital. But for somebody to adopt that technology and put it to use, somebody has to wrap it and provide a performance guarantee. Otherwise, it's not bankable. These startups don't have the balance sheet to do so. And EPCs who will build these plants will not be able to wrap it because it's not their technology. It's not been built to commercial scale. So those who have crossed that valley are the ones that survive. So Mr. Bill Gates called on a few of us in industry that this is the role that big industrial OEMs need to play. Adopt a startup technology and help them get over the hump. Otherwise, the technology is not going to flourish or proliferate. That has such a deep meaning because it is so true. But it's really hard right now.
So you're such a strong advocate of just addressing climate change, decarbonization of industry. What keeps you up at night?
Well, as you can see from my gray hair, I've been around the block a while. During my lifetime, I question sometimes, what can I really do to move the needle? Am I doing enough? Am I leaving something that my children or my grandchildren, I don't have any grandchildren yet, but am I doing the right thing for this world? Am I doing enough? Am I slacking off? That does keep me up at night.
That's really inspirational. Well, I think we have just a minute left, and I guess, so what's next for industrial decarb?
Well, let me turn the scales here, Evelyn. You led DARPA-E. ARPA-E, I'm sorry. You now went back to your old school. You run a very innovative program. What are you doing? Why don't you tell the crowd what you're doing?
Okay, I'll try to do this in 50 seconds.
Yeah.
And certainly I think I resonate very much with your comments because there is an opportunity for more innovation to really tackle this problem of industrial decarb. And I think from a university perspective, very much of what you said, Tak, is to now think about how do we seed more of the innovations, but it's not just about innovation because there's so many valleys of death. And is there an opportunity to now partner more closely with the industry at the early stages to actually address problems that matter? There's so many problems that we can solve, but they may not matter. And scaling these kinds of solution sets are hard, as we just talked about. So the way we're trying to frame the problems and the solutions are very much in that mind, and creating the partnerships that are needed with industry, with the private sector, to work with investors at the very early stages.
And that's what you lead at MIT.
And so that's what I'm leading, and really trying to address climate change. We have a project called the Climate Project, really thinking about ultimately how it impacts people and communities, but working with the lens of engaging with partners across the ecosystem.
Thank you so much for continuing this.
Yeah, thank you. Well, thank you, Tak. I know we're out of time here, so thank you so much for sharing.
Thank you
this
so
great
much for having me
perspective.
here.
So, thank you.